Balls of Fury is a 2007 action comedy film that's, well, awful. Terrible writing, campy action. It's also really, really racist. But that's a different story. There's one thing about the movie that made me think, believe it or not. After watching it and seeing some of the action sequences, I wondered how accurate the physics of the film were, and, well, I was less disappointed than you'd think. I took 2 scenes from the movie and worked out their plausibility with physics problems, checked the solutions, and tried to figure out how far off they were. Alright, let's get into it. Scene 1. The steel drum. In this scene of the film, the main character hits ping pong balls against a steel drum to play a song, which is already kind of a fail in itself.
I don't want to work. I just want to bang on these drums all day long, am I right?
If we set all this aside, let's assume that he can juggle this many balls without them hitting each other, and somehow he can play the song against the steel drum. The thing that bothered me when I watched this scene was the projectile motion of the ball. How was it possible that the ball could be traveling so slowly and still reach him? After putting the clip in tracker, I made the realization that the ball is moving at about 8 meters per second on average when it's leaving his paddle and heading towards the drum. I had no idea what the spring constant of a steel drum is, so I don't really know how exactly bouncy the ball would be against it. But again, for conservation's sake, let's assume that this collision is perfectly elastic. The walls of the steel drum are all different thicknesses and are all cut at a 45-degree angle. Assuming that the balls can hit perfect notes against this drum, that would mean they would have to hit the steel drums right at the center spot. If the ball is leaving the drum at a 45-degree angle after hitting it horizontally, it should drop from about 8 meters a second to about 5.65 meters per second. However, after watching the ball come back towards the guy from the film, one can observe that it's actually fallen to only 3.75 meters per second. Now I know that I can't say this is debunked because I'm assuming that collision is elastic and the ball is entering more or less horizontally, but the principle sticks. While it may not be perfect, I think one can assume that the material it bounces on and the angle it comes in won't give the data a 33% error. I'm calling this one probably debunked. Yes, that's the main character having an epic ping pong battle with a 12-year-old girl. Details aren't really that important here. What's important is the speed of the rally. If we look at the rally from Balls of Fury, we can gather a good amount about the ball's speed. The length of a regulation-sized ping pong table is about 1.5 meters, so I set that as a calibration tape and tracker. As we can see in this clip, and from the graph, the ball is moving back and forth across the table, a distance of almost 3 meters. In only 0.333 seconds, giving it an average velocity of about 9 meters per second. This seems obviously very fast, but it is technically physically possible. The only problem is that very few humans could ever hit a ball at this speed, especially not competitively or as a 12-year-old girl. To compare this as a baseline, I used a clip from the 2008 Olympic qualifying trials in table tennis for my example. In this clip, the man spikes the ball, moving it even faster than a sustainable rally in Balls of Fury. But there, and in this, there's the problem. In just 0.3 seconds, the ball travels a distance of just 2 meters, making it barely over the length of the table and back in the reach of the player standing behind it. This means that a top-notch player hitting the ball as hard as he thinks he can during competitive play only got it to about 6.86 meters per second. Again, I have to call this one probably debunked. Maybe the Olympian had stage fright, who knows? But at the end of the day, it seems extremely unreasonable that someone could hold up a ping pong rally at an amateur level trying to seriously play at that speed. As you can see, the physics of Balls of Fury are not realistic, but trust me, if you watch this film, that's the least of your worries. It's pretty heinous overall, but for all the question marks that I had about the film, the physics wasn't even that big of a deal. If you have to watch it, I'd recommend getting drunk, because that's the only way this movie's gonna make any remote sense to you.